Hello, today we are going to talk about polynomial regression. I'm recording this video for TA application of Computational Neuroscience for Neuromatch Summer 2023. So let's talk about me. My name is Amir Hossein Darai and I'm studying biomedical engineering at Johns Hopkins University. Here, I'm a first year PhD student. I'm working with Dr. Sridevi Sarma, Dr. Adam Charles, and Dr. Juni Kang. And I'm studying the neural representation and dynamics of epilepsy patients that lead to epilepsy. As my background, I worked on robotics and made rescue robots for a few years. And also, I was working on sleep data and sleep variables in Donders Institute in Netherlands. So let's talk about polynomial regression. First thing first, I have to say that it's a linear method. And I'm answering 3 different questions about this. Basically, what is polynomial regression, when do we use it, and how should we use the polynomial regression? So, asking the what question, I should say that the polynomial regression is a machine learning model that can capture nonlinear relationships between different variables by fitting a nonlinear regression line instead of a linear line. So when should we use and fit a nonlinear line to our data? We use that when the linear regression model may not adequately capture the complexity of relationships of our variables. So basically, when we have independent variables that do not have a simple relationship together, they have a complex non-linear relationship together. How does this magical method work? It's really interesting that the linear model can capture nonlinear behavior in our independent variables. So the way that it works is that we still have the same independent variables that we had before. Nothing changed. But in linear regression, our design matrix was simply like this. So we have a column of 1 stacked with the different columns of our different independent variables. For polynomial regression of the order k, what we do is we design our design matrix differently. What we do is that we raise each independent variables from 1 to the power of k. We stack them together, each independent variable group by group, and we make our design matrix. And from our linear regression model, we knew that we are modeling our data like this. And using cost function and pseudo inverse, we can find our parameter. We can infer our parameter from the data using this normal equation. So what I'm going to do right now is I'm going to walk you through a coding exercise, basically answering this question of how can we code and design a design matrix which fits the polynomial regression models well. And we can use that design matrix as the x vector for the polynomial regression. The function that we are going to design and write together would take columns of independent variables in a matrix X, and then the output would be another matrix which I call X again, but in this way. So we have a column of 1 and we have our independent variables raised to the power from 1 to k stacked all together. Let's go through the coding exercise. So first thing first, I'm importing numpy and I'm making my x to be 40 different numbers, 40 different indices, and 2 different independent variables from -1 to 2, and you can see it visually here. Then this is a function that we have for making the design matrix. In this function, we should see what is being done. First, let's see the output of this function. The output is a 40 by 11 matrix. Think about it. How does that work? The order of our regression is 5. The order of our design matrix, the order of polynomial regression is 5. What does that have to say to us? So if I show you the X design, which is our design matrix, you will see that we still have the column of 1. We have the first independent variable, and then we are raising it to the different powers and stacking them one after the other. First independent to the power of 2, first independent variable to the power of 3, first independent variable to the power of 4, first independent variable to the power of 5, and we go to the second independent variable, go on and so forth. So here, when we input our X matrix, which is a simple matrix that I have showed to you before, we first of all create a column of 1 with the same number of columns. Then we go one by one from 1 to the order of our polynomial regression, and we bring our column vector to the power we bring our X to the power of the degree. So we have those two columns, we bring that to the power of 1 in the first iteration, and we stack them to our design matrix. Then we have those two columns, we bring them to each of elements to the power of 2, and then we stack them to our design matrix. And as you can see, we're gonna do it up to the power of order plus 1, where in Python we know that the range goes from 1 to order plus 1 minus 1, so which would be the order. So if the order is 5, we're gonna have those two columns, each element raised to the power of 5, and then stacked to our design matrix. And basically what we're gonna have here is that this one is the intercept, the ones. This one would be x1 and x2. Here we have x1 to the power of 2, x2 to the power of 2. Here we have x1 to the power of 3, x2 to the power of 3, and so on and so forth, up to the x1 to the power of 5, and x2 to the power of 5. So with this, we're going to have this matrix which would fit our model very good, and we can use it in our model to find and infer the theta, basically using a linear model to capture a non-linear relationships between our independent variables. I hope I explained it well to you and you understood that. If you had any question, please reach out to me, and have a very good time, and I hope all the best happened to you today. Have a good time in Neuromatch. Goodbye.